Okay, so this particular sheet is in your packet, and I wanted to have you try it first. Have you try it first, and then then you can pause, and then I'm going to go over each of these answers. Okay? So let's see if I can highlight on this thing. I'm not sure if I'm going to be able to. I can use different colors. I think that's the extent of it. Okay, so we want to highlight the functional group. And the functional group is hydroxyl, so we'll show it like that. Class of compound is an alcohol. And we should really name it too. I don't know why we just want to do that. We're going to name each one of these, right? Because it's really the essential part of it. So if it's an alcohol, I found out how many carbons there are. Meth, eth, prop. So this is propanol. When I'm naming, it's an O. When I'm naming alcohols, I also have to name the carbon to which they are bonded, the hydroxyl group. So this is 1-propanol, OL. Okay? And by the way, this is a primary alcohol. Primary alcohol. Number 2. All right, so I've got an O in the middle. An O in the middle, and I've got carbon chains on ether side of it. So this is an ether. Okay? This is an ether. When I'm naming these things, I name them alphabetically. So if I've got an ethyl and a methyl on both sides, or either side of that, then I put them in alphabetical order. In this case, both of these are the same. So it's, instead of saying it twice, I have to put a di in there. So the functional group is shown like this. And then I put diethyl, ketone. Okay? Just a second. I said ketone, I meant ether. So ethers always end with ether. So this is a diethyl ether because I've got 2 of them. Number 3. Oh, I should be highlighting this. That's the group. Here's the group. This is an alkyl halide. Alkyl halides, they could be formed from, this one has to be formed from a substitution since there's only 1 carbon. Okay, so this is called chloromethane. Or it could be called methyl chloride, either one. And it's like this. Or it could be a halide of some sort, any other halide. All right, number 4. I think I have to erase this. Yes, I do. Move this up. Number 4, here's my operative group. Okay, so that's R, C double bonded O, and H. Sometimes you'll see it like this, sometimes you'll see it like this. I can't put OH because that would be an alcohol. This means that it's an aldehyde. Okay? So aldehydes have the ending AL. And I count my carbons. 1, 2, 3, 4, 5. Meth, eth, prop, bute, and pent. This is a pentanal. P-E-N-T-E-N. P-E-N. Pentane, sorry. P-E-N-T-A-N-A-L. Pentanal. I don't have to number it because they're always at the end for aldehydes. Number 5. Here's my group. And this group is a ketone. Sometimes you can actually see that it kind of looks like a key, this little part here. I don't know if it helps. Okay, when I'm naming these ketones, they end in -one. So I'm going to put these, I have to number these, my carbons. So I'm going to number the carbons with that at the lowest carbon that I can. So I'm going 1, 2, 3, or I could go 1, 2. So this is 2, so I'm starting from left to right. So this is 2, and what's my long? 1, 2, 3, 4. That's butane. And then I finish it with -one. So 2-butanone. Okay? 2-butanone. The group here is RC double bonded O. And then R prime. Number 6. Okay, so here's my group. That's RC double bonded O, O, and then R prime. And in this case, we've got she-cool, so this is an ester. Ester's cool. So, in this case, I always name the one that is attached to this oxygen first. So that's methyl. Then I count my number of carbons, including the carbon that's here. So that's meth, eth, prop. And that's propane. And then, remember, ester ate a lot. So ester is methyl propanoate. Methyl propanoate. All right? Let's go to the back. Number 7. Number 7, we've got, now they're repeating a little bit. There's a couple new ones here, but they're repeating a little bit. I've got an O in the middle, and this is R-O, R prime. That means that there's an O in the middle, and there are two things on ether side of it. So this is an ether. Remember, ethers end with ether. So I name the groups. Methyl, there are 2 of them, so this is di-methyl ether. Okay, number 8. Number 8, we've got a C double bonded OOH there. That is an acid group. When I name acids, I count the number of carbons. Meth, eth, prop, and bute. So this would be butane if this were just a hydrogen. And the ending of that is butanoic. I add oic, so that's butanoic acid. This is more commonly known as butyric acid. I reminded you once, it's the smell of your feet that's picked up by hound dogs if you're on the run. That's butanoic acid, and its group is shown like this. Number 9. Here's an OH. That's the first one we learned. That's the hydroxyl group, and that's with an alcohol. When I'm naming these, I have to number the carbon to which the hydroxyl group is attached. So in this case, it's 2. It's right in the middle. How many carbons? Meth, eth, prop. That's prop. It would be propane, but OL indicates it is an alcohol. And this is actually a secondary alcohol because that carbon is attached to 2 others. And my group would look like this. All right, let's switch colors again. Number 10. You can see that the substituent group is a bromine, so this is an alkyl halide again. And And what do we have here? We've got meth-eth-prop. So this is propane. And I name the carbon, number the carbon. So this is 2-bromo-propane. 2-bromo-propane. Okay? And how would I do my grouping? I would do R, and then in this case it would be a bromine. Let's see exactly what they do with the, oh, they do RX, because it could be any of those. Okay, so you could have it like that, or you could have it like that. All right, number 11. Here's a new one. Looked at this the other day. That's an amine group. It's an amine group. So for that, it's shown like an NH2. And when I'm looking at those, I have to number the carbon to which the amine group is attached. So that's 1. Then I write the word amino. And then I name meth-eth. That would be, if the hydrogen were right there, it would be just 1-amino ethane. Okay? And this is called an amine. Not to be confused with the next one. Excuse me. Move this up. Which is an amide. Where are we? Right here. Okay, so this is the whole group. And that's going to be a CONH2. I probably should confirm that. They only show the one H. Okay. You're rarely going to see this particular one. This is called an amide. And I'm going to name this by counting the number of carbons, which is 2. That's meth, then eth. I use the base name, ethane, and then I just add amide. This is just called ethanamide. Okay? All right, here's your key. This is a ketone. And in ketones, I'm going to name the carbon to which that has the carbonyl group. So this is 3. And what's my long? Meth, eth, prop, bute, and pent. So this would be pentane. And then in ketones, they end in -one. So 3-pentanone. And this would be R, C double bond O, and then R prime. 2 more. 14. C double bond O, OH. This is an organic acid. I count the number of carbons. Meth, eth, prop. It's propane. And then I add oic, propanoic. Add the word acid. Propanoic acid. In this case, I've got R and then COOH. And lastly, I've got a C double bonded OO. She cool. This is ester. I name the group that's attached to that oxygen. So that is an eth, meth, eth. So that's ethyl. Then I name the other, which is 1,2 carbons. It's also ethyl. But I just put ethane. I take the E out, and then O8 because Esther, she ate it. So this is ethyl ethanoate. Ethyl ethanoate. So that's R, C double bonded O, O, and then R prime. Okay? So hopefully that helped. I will also post the answers to the review book questions so you can use those for practice if you'd like. All right? Good luck.